All right, so 113, we're going to be learning about place value and dot patterns. So hopefully place value is going to be a lot of review for you. So we're going to kind of just brush over it really quickly, do a couple examples, and then I really want to focus on dot patterns, which are going to be on the back side of your notes. So let's get some vocab out of the way. Get all this set up. So it says the number assigned to each place that a digit occupied, that's called place value. In our number system, the place values are all powers of 10. What that means is it goes up by tenths each time. So if we're at our decimal point here, we start out, if we go to the left, we go to ones, and then we multiply that by 10, and we get tenths, or tens, no th, sorry about that. Then we multiply that by 10, and we get hundreds. Then we multiply that by 10 and get thousands. So every place value that we move to the left, we're actually multiplying our number by 10. Okay? So starting from the left side of the decimal point, like we just went over, are ones, tens, hundreds, thousands, 10,000s, and so on. Now if we went the opposite direction, going to the right of the decimal point, we start at tenths, and then we go to hundredths, and then we go to thousands. So hopefully you notice that behind the decimal, we add a th to the place value, okay? Because the th, we're taking a tenth of whatever, or we're taking a hundredth of whatever. So we add a th at the end. Another thing I want you to notice is that they have the same pattern going each way. So again, let's focus on our decimal point. Let's go to the left. We have ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, so on. If we go to the right, we have tenths, hundredths, thousands, 10,000s, 100,000s, millions, and so on. The only difference is this one, okay? Behind the decimal point, we don't have a place value that's labeled a oneth, okay? And that's because in math, if we have one of something, we consider that a whole, okay? If I have one cupcake, I have a whole cupcake, right? I can't have a oneth of a cupcake, okay? But I can have a tenth of a cupcake, because what that means, a tenth, what that means is I cut my cupcake into 10 pieces and I took one of those pieces, okay? But I can't cut my cupcake into one piece and then take the one piece. No, I'm just taking a whole, okay? So that is why behind the decimal, we do not have a oneth. But we do have a tenth, hundredth, thousands, and so on. So it does follow the same pattern, just without the ones place, okay? And it's super important, behind that decimal point is a th. So if we were going to read this number right here, we read that as 9,876 and 543 thousandths. Okay, that last word when we write these numbers out right here is whatever number we end, or whatever place value our number ends in. Okay, we ended in the thousandths. So that is why we added thousands to the end. Okay, one major mistake is if I see this number, people say 103. Okay, no. Anytime in math you say the word and, that tells me that's where my decimal is. So if I read this as 103, what I really just said was 103. Okay, and those are two different numbers. $103 or $100.30. Okay, so just be aware that when you say and in math, that is where your decimal point is. So it sounds a little weird to say 103. Okay, it doesn't really sound very proper, but that's actually how you say it. All right, so let's do some examples. So down below, we gave you the number and we want you to write it in words according to place value. So this first one, okay, you see we have 64.3. Okay, so how would we say that in words? So we have our, oh, let me make my, so we have our 64, and remember in math, and means the decimal point, and 3, and then we finish it off with whatever place value that 3's in, and it is in the tenths spot. So how I would say this number is 64 and 3/10. So go ahead, use what you know about place value and what we just discussed, and try number 2 and 3 on your own. So pause the video, try them, and then come back. Okay, let's see how you did. All right, we see here in number 2, 7.17. So how we would say that is 7 and, remember, and means our decimal point, 17, what place value is that in? It is in the hundredths spot. So 7 and 17 hundredths. One common mistake I see students make when we're doing place value is they'll say 7 and 1/10 7/100. And I mean, I guess technically you're right, but that's not how we say it. We still say it how you see it. You see that as 17. You just got to put your place value on the end. So this number right here, okay, this one's a little different because we don't see anything in front of the decimal. So when you don't see anything in front of the decimal, you can kind of ignore it. You don't really have to say anything. You can see we have the number 9 and it's in the hundredths spot. So how we would say this is 9 hundredths. Now, if you would like to, you could say 0 and 9 hundredths, which is fine. It's still correct, but you just don't have to add that in. So if you had that as an answer, that's totally fine. You just don't have to write the 0, okay? So down here now we're going to reverse our thinking. So instead of writing the word form, it gives us the word form. So now our job is to write the decimal form. So this one says 58 hundredths. Okay, so I don't have any and, so I know I don't really need a decimal point in there. Or I'm sorry, I need my decimal point, but I'm not going to have anything in front of my decimal point. So 58 hundredths. So what this tells me is that my number is going to end in the hundredths spot. So then I just fill in my number and then fill in any zeros if needed. So go ahead, pause this video and use what you know about place value to try number 5 and 6 on your own and press play when you're ready. Okay. We have, for number 5, it says 2 thousandths. Again, I don't see the word and, so I know nothing's going to go in front. And I know we're behind my decimal because I see that TH on the end. So 2 thousandths. So what I always do is I always write, okay, here's my decimal. I have tenths, hundredths, thousandths. So I know my number is going to end in the thousand spot. Well, it's only the number 2. And then I just fill in these empty spaces with zeros. You don't necessarily have to put a 0 in front of the decimal, but I will tell you in math it is very helpful, especially when you're going to start lining these up to add or subtract. It's going to be very helpful to get into that routine. And sometimes your little decimal point can get lost, so that kind of helps us. 6, 9, and 3/10. So I see the word and, so I know I'm going to have something in front of my decimal. And then 3/10, I know tenths is just one place behind. So 9, and is my decimal, 3/10. And I don't need to post any zeros in there because there's no empty slots. So that's it, 9.3. All right, go ahead, flip to the back. We're going to start patterns. So on the back, it says, patterns are everywhere. You may have noticed them in pine cones, flowers, stacks of cans in the grocery store, or many other places. Patterns are interesting partly because of the different ways that you can see how the parts of the pattern are changing. In this course, you will often be asked to look for different ways of seeing a pattern or a concept. As you study the pattern in this lesson, work with your team to find several ways to see and describe the pattern and how it's growing. So, let's look at this pattern that we have. This is what we call a dot pattern. Okay? And I hope it's very self-explanatory why we call it a dot pattern. Well, that's because it's made of dots, right? So, let's look at figure 1 and figure 2. Let's just focus on those two. Okay? How is it changing? So let's just look at that. So I see figure 1 has 1 square, and I see figure 2 has 2 squares, right? All right, so figure 1, I have all of this. And then so if I highlight all of that in figure 2, okay, what was being added? Well, it was this little piece right there, right? So I'm adding this little backward C. So let's go to figure 3. All right, here's my figure 1. Here's what we added to get figure 2. And then figure 3, oh, I added another backward C. So you can see it's kind of growing by this backward C each time. So let's use this information and let's answer what should the fourth and fifth figures look like. So go ahead with what we just noticed, draw what you think the fourth and fifth figure would look like. All right, hopefully yours looks a lot better than mine. But here is figure 4, and here is figure 5. Trying to write these on the computer is a very hard task to do. All right, so if we look at our figure number, okay, we just discussed that it's growing by a backward C each time. Okay, so that's all I did. For figure 4, I drew the same thing I saw in figure 3, which was this little piece right here. And then I added this backward C on it. Okay, then for figure 5, same thing. I drew figure 4, and then I added this backward C on the end. Okay, so the next question is asking us, how is our pattern growing? How can we describe it? So when we say describe, we're wanting to use words. Okay, so one way is we are adding a square each time. Okay, we noticed that right when we were kind of going over it. You could say adding a backward C each time. What about specifically? What about specifically to the number of dots we're adding each time? Okay, so let's look at how many dots we have in each figure number. So if I count the number of dots in figure 1, so I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Same thing here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So from 8 to 13, how many dots were we adding? Hopefully 5. From 13 to 18, how many dots were we adding? 5. right? So we can see the pattern is growing by 5. And if you count the number of dots in figure 4, you'll see that that's 23. And in figure 5, that's 28. Okay, so again, still growing by 5. So that's, you want to check a couple times to make sure it's going to happen each time, but this is consistently growing by 5 each time. So we could also say growing by 5 dots each time, okay, if we want to be more specific. All right, now it says how many dots would be in the 10th figure. So we know how many dots would be in each one, and we know how much it's growing by each time, okay? So sometimes in pattern questions, they'll ask us how many dots will be in a further down the line figure number. And sometimes they can ask us a pretty big figure number. Look at question D. How many dots would be in the 30th figure? Do you really want to be able to sit or have to sit there and draw out 30 of these figures? And I'll tell you, on our test in chapter 1, I believe it asks you to tell me how many dots are in the 100th figure. Do you want to sit there and draw this out 100 times? No, you have way better things to do. So I'm going to show you a pattern, okay, or a little trick to help you out. And by saying that, we are going to come up with an expression. So we're going to come up with a little expression that we can plug in the figure number and find how many dots would be in there every single time, okay? And the first thing we do was to find how much our pattern is growing each time, and we did that. We saw that it's growing by 5. So what we're going to call 5 is our multiplier, okay? And hopefully what you're going to see is that there's going to be a relation between your figure number and how many dots are in your pattern, okay? So when I say a multiplier, what I mean by that is you're going to take your growth number, or your multiplier, times the figure number, okay? That's going to be our first step. So I see our multiplier is 5. It's going up by 5 each time. So let's look at figure 1. So like I said, we're going to take our multiplier and multiply it by our figure number. So 5 times 1 is 5. Does that give us how many dots are in our pattern? No, because we have 8 dots. So sometimes it's not going to work out perfectly. Sometimes after we multiply, we might have to add or subtract something each time. So 5 times 1 is 5. How much do we have to add to get to 8? 3, right? Okay, well let's see if that works each time. So our multiplier is 5, and then we add 3. Let's see if that works for figure 2. So 5, our multiplier, times our figure number. Okay, so 5 times 2 is 10. Again, that didn't give us 13, but remember, in the last one we added 3. Did that give us the number of dots? Yep. Let's try our figure 3. So we take our multiplier, or our growth number, 5 times our figure number. That gave us 15, okay? We're not quite at the number of dots, but what do I have to add to 15 to get to my 18? Well, that's just 3. So you can see the pattern. If I take my multiplier, multiply it by the figure number, and add 3, that'll tell me how many dots are in my pattern each time. So when it says how many dots would be in the 10th figure, oh, okay, easy. We'll take our multiplier, 5, times our figure number, which in this case is 10. So 5 times 10 is 50. But remember, we have to add 3. So how many dots are in the 10th figure? 53 dots. And you don't have to draw it up. That's a lot of drawing. All right, let's try D. How many dots would be in the 30th figure? Well, you really don't want to draw that one, right? That'd be a ton of work. So let's do our little trick. So we have 5 as our multiplier. That's what it's growing by each time, times our figure number, which in this case is 30. So 5 times 30 is 150, but remember, we had to add 3 to make it correct. So there is 153 dots in the 30th figure. So we'll do a lot more practice with these, so if you're kind of confused, don't worry. Make sure you bring these questions for when I'm back. But we just take our multiplier or our growth number, multiply it by our figure number, and it's not always going to give us the perfect number each time, and that's okay. That just means, okay, each time we'll have to add or subtract something. All right, and that is 113.